back here a little bit so you can see me on that camera. Thanks for having me. Thanks for coming. My name's Neil Webster. I've been sort of in the drill and blast industry for about 22 years now or so. And actually, what I realised when we booked this venue tonight, I've only ever been here once, and it was about 20.
Hey, man.
Right, Barry. Yeah, 23 years ago, I did a little presentation here for my first year at university at Doncaster. So it's quite fitting, really. Quite nice to be back here doing another one. So I'll give you a bit of background on Woodsmith, because some of you will know bits about it, some won't. Where are we? We're at Whitby, North Yorkshire. And what are we doing there? Well, we're building a mine to reach what's known as polyhalite. Polyhalite's a naturally occurring mineral comprising of 4 of the 6 macronutrients that plants and crops need to grow. And you can see the red line on the map there, a bit of an extrapolation of where they think the resources go to. So there's plenty of polyhalite, 100 years plus. So the aim is to construct the mine, get down to the polyhalite, and obviously sell it. And what you can see, the image in the top left-hand corner, the product, you don't have to do anything to it. Yeah, so we get the product, we mill it down into the balls. There are some other things that they can add to it, but basically it's pure. You just put it on the crops. That's why its value is so high, because there's little processing involved in it. So that's a bit of a generalized overview of the project. It's not to scale. So if you look at down the left-hand side, you'll see that's 1,600 meters, a mile. But from left to right, it's sort of 37 kilometers from Whitby to Middlesbrough. So the diagram's not to scale, but it does show you the 2 deep shafts that we're constructing, service shaft and production shaft. They're a mile deep, vertical mile. And the tunnel is approximately 37 kilometers long. And you can just see, I'll have to point on this, just to the little shaft here, the MTS shaft. That is where my job, when I was taken on, that was kind of my role, was to blast that small shaft. Because the other 2, the deep shafts, are going down by what's known as the shaft boring road headers, which I'll show you in a moment. So if I just shrink that diagram up a little bit, see what we've got. There's a bit of a Google Earth image. Middlesbrough's on the right, Whitby's sort of towards the left. So that's where the mine site is, just on the hilltop at Whitby. Then we've got 2 intermediate shafts, Ladycross and Lockwood Beck. Then we've got the materials handling facility, where it's ground down into them little balls, and connecting them all is the 37 kilometer long tunnel. And you can see on the image there, Stella Rose. I think she set off in around 2017. But the original plan was to have 3 TBMs. One dropped in at Wilton, 1 at Lockwood Beck, and 1 at the mine site at Woodsmith. But in 2019, when Sirius Minerals couldn't fund the project any further, the decision was made to take those 2 TBMs out of the equation. What that's meant is Stella Rose setting off from the Middlesbrough side at Wilton there. She's now sort of broken a few world records because she's she's done far more than what she was planned to do. So if we come to Woodsmith, it's an old photo, but the site looks pretty similar to that now, really. So for the people online as well, the tall tower on the left is the MTS shaft. So that was my main area of work. That's the short shaft, only 335 meters deep. The two sort of buildings down the centre, the boxy ones with the sort of very shallow triangular roofs, that's your service and production shaft. So they're the deep ones. But with this being the mine of the future, that's kind of the generated image that they want it to look like once we're finished. So take away the tall MTS shaft, take away all the construction activities, plant lots of trees, lots of bunding, and mask the site. So I mentioned the SBRs. These are, I think they're about 65 meters tall. We've got two of these in the ground as we speak. And these are basically, if you will, a tunnel boring machine, but vertical, yeah? So Herring Connect design, and it basically, you can see the cutting head there, that spins, and then the arm swings, and it basically cuts what we call pizza slices out of the rock and just keeps moving downwards. And that's what one looks like when you stood underneath it, basically. So that's about 3 meters up from where I took the photo. And that's me stood with it above my head. And they do a real good job. I mean, look at the walls of that mudstone there, just real neat cut, and then ground support, which is above the yellow mesh and the bolts in the wall. So it does a fantastic job, to be honest. It cuts the rock into small pieces and then hoovers them up. And there's a close-up of the wall. So moving on to coming away from them deep shafts now, because we'll not talk about them, because you could spend a whole presentation just talking about the deep shafts. So you can see the area in red, the small shaft. That's where my sort of skills came in. That was to blast this shaft down. You'll notice it's a bit of a T shape. You'll see why later on. It opens up into a cavern. But then the other areas that needed blasting that I didn't know about, and I don't think anybody really knew that we would need to blast these, are these very small, the little white rectangles that are on the deep shafts. They're like water pumping stations. We call them water cubbies. They're about 4.2 meters wide, 4.6 meters high by 14 meters long. Again, not to scale, but just to show you where. So there's 8 of them, 4 on each shaft to do. I'll go into that in a minute. Then there's a potential that we might need to assist the SBR to get through this sandstone band that you can see in orange on the screen. And that's what we're getting ready for that at the moment. So there's the MTS shaft. That's been my home for the past 4 years, basically. Inside there, we've got, so the SBRs are like the modern day shaft sinking machine. Yeah, if you've got the deep shaft and the right rock conditions, those machines will chew through it, and you can concrete up and ground support at the same time. What we've got at the MTS shaft is what's known as the Gallagher stage, or some people might call it just the stage. This is what's called like the conventional method of shaft sinking. So this is what you would have seen over the past 50, 60 years. And it's basically a 5-decked metallic structure that's hanging on steel ropes in the shaft. The middle photo is the stage being lifted in. I think that was about 2017 as well, maybe a bit later actually. And then just a very basic image off Google, that one actually, just to show you the blast at the bottom with a bucket. So that's me gone into the MTS shaft. We've got a man riding bucket on the left and a muck bucket on the right. You can interchange these. You can have 2 man riders on or 2 muck buckets. And basically them they lift them up and the doors open and you head in. So that's, you can see the Gallagher stage there in front of me as I'm going down. We've got ventilation down here. There's the Gallagher stage. That's about 25 meters of them 5 decks. There's a fresh blast ready. Oh, that's me going in to do my post-blast inspection on one of them. But just take a mental note of these 2 bucket wells, as we call them. They're only 1.9 meters in diameter. So that's like, say, the height of me. They're not massive. Just take a mental note of that and we'll come back to that later on. That's me looking back up the way. 2 bucket wells, and you can see one of the bucket wells has got like a man rider in it, probably just parked up at deck 4 there. Just another, this image, yeah. So this, another image looking up at this one, you get a better feel for, see these two items here. So these are what we call VSMs, vertical shaft muckers. And they're the things that come down to grab the blasted rock. So where they're locked in position there, we unlock them, lower them down, and they reach the blast, yeah. So they live there all the time. But the jumbos, I'll just show you a picture of the grabs here. Go on to the jumbos in a minute. Again, just some pictures off YouTube and that, really, in Google. It's quite difficult. There's an image of one coming down. It's difficult to get images of them working because it gets a bit dusty down there, a bit noisy. I like to stay clean. So the jumbos, these are slightly different. So these don't live on the Gallagher. So this is what we used to drill the blast holes. Again, monsters, 14 meters long, I think they are. They'd be well suited to a harder rock, like a granite, really, them hammers. We were in a soft mudstone, so they just drilled the holes, no bother. Hardly used any drill bits, yeah. But they live in that tall tower at the top of the shaft. And when we need them, we crane them in, lower them in, and they sit in them 2 bucket wells, them 2 circles. We drill the holes, then we send them back out. So they're not in the way then, yeah. Drill rods, top hammer, T48, 4.8 meter long. That allowed us to drill roughly a 4.5 meter hole. So when we went down with the explosives, it'd be about a 4.5 meter hole that was charged, yeah. Button bits there. You'll see on that little image from Boat Long Year, cross bit, a button bit and a cross bit. We did give the lads the cross bits as well, and we were sort of hoping for some feedback as to which was quicker to drill a hole. To be honest, it came down to personal preference. Some lads preferred the button bits, some preferred the cross bits. And then the white drill bit there is a 127 mil bit, but it's got a little pilot bit on the front. So we used to use them to drill the void holes, which I'll explain on this diagram. So the image top right is a tunnel I was on. And if any of you are familiar with underground terminology, the sort of cluster in the center with the crosses, that's like the burn cut. That little area. So it's an area of high charge. You've got more explosives in that area to help break the rock out and everything to move in, the rest of the blast to move towards. But it does have them crosses. They're a bigger hole. So they're the 127mm holes, but the left empty, called void holes or ream holes, depends which jobs you've been on. So you saw the white drill bit, it's quite a big difference. So the other drill bits we were using were 64mm for the blast holes. So basically, I'm showing you that because quite simply, we just, to blast the shaft, we're obviously on the floor, vertical holes, but we've basically just taken the burn cut and thrown it onto the floor there, cluster of holes. Although I have got, on that one, I've got 8, so there's only 4 void holes there. And I had 8 there. We did cut that down to 6 to save a bit of time. The results were pretty much the same, so that was good. But yeah, I've got 4 different types of holes there. We've got void holes, also known as reams, 127mm, they're blue. Cut holes, 64mm in red. Bulk holes, 64mm in yellow, also known as maybe ESA holes. And then the perimeter holes in green, again, 64mm. But you notice the green ones are quite close together. So we tried, it wasn't pre-splitting, which some of you will have done. It was more like that smooth blast effect. So in them green, in the perimeter holes, we had Orica Senatel power split, the sort of pre-split design product. But when we fired it, it fired from the burn cut outwards, and the green holes fired last. Whereas a pre-split, you'd fire them first. We did try a pre-split actually, and it didn't work. I was warned that underground pre-splits don't tend to work, but we gave it a go, and it sort of half the blast, as they dug down, half of it kind of worked, but there wasn't enough free face for it to work somehow down below, and the bottom half was real tight to dig.
How can your burn cuts off centre?
So the burn cut is off centre for 2 reasons. When we started the first couple of blasts, we did it with let's call it a UK workforce. As blast number 3 came in, we'd taken on a Canadian shaft sinking company, Redpath. And in the Canadian law, you're not allowed to have the burn cut in the same place each blast. So you have to move it about. So on a tunnel face, they'll move it from left to right, left to right. And straight away, we had it in the centre. And they said to me, you can't do that. And I said, well, we're not in Canada, but we'll do it because the other risk is that if you have any misfires or little bits of remnants of explosives, when you clean the bench and you come to drill again, you're sort of drilling that concentrated area in the same place again. There is a risk that there might be something there. So it's good practice to move it about. So what we did, we used our brains, we located it, let's call it north and south or top to bottom. So we moved it top to bottom on that diagram, which married in with them holes, the bucket wells. So when the heavy charge of the burn cut is shooting up, it was not damaging the Galloway as much because the rocks were sort of almost they had a free hole to go into. So that's why it's off centre, yeah. So to get them holes that you saw on that plan marked out, I've done many quarry blasts where we use the rocks and spray paint. So I did try that, but we noticed everybody kicked the rocks away because it's such a tight space. So this little device, I made it pretty much homemade, just a piece of 110 volt cable with a bit of plywood, bit of paint, tape. And then you'll see we used little metal plates from the rock bolts, the ground support plates, sprayed them up, and these stayed in place. So even if they didn't really get kicked about so much, but even under the water, you could sort of feel around and you'd feel the plate. So it's good for the drillers. So anyway, get shafts get the shaft tech to give me the center of the shaft, put the little device on. I've measured my little markers on the yellow cable, little markers, you can just see them. And as I pull it out on these angles on the board, wherever I got my fingers got to a marker, that's where I sprayed a dot. All sounds a little bit like not very scientific, but the result was great, because you would get these nice arcs, everything measured out exactly how I planned it on the Orica Shot Plus software. And you can see on that diagram, you can see on that photo, you can see the perimeter holes around the edge, the white sort of marks on the wall. So that the lads were told just to drill as close as they can to where the two lines cross over. And this one here, this was the biggest blast we did, and it got a bit technical. We had 3 burn cuts. You can see three clusters. We started using the laser to try and mark it out, and it was such a faff. I got my tool out, and I'd probably marked 20 holes by the time he got his laser on one of them, and that was done all with that little homemade tool. That blast, you'll see it in a bit, not a video, but a 3D image of it. Nearly 2,000 kilos in that, 1,927 kilos. I know that's not a lot in quarrying terms, but for us, that was absolutely massive. That was like 4 times the size of a normal blast. So there's the jumbo. So I've marked that blast out, for example. You can see the burn cut, the cluster in pink, and there's a jumbo locked in, just opened up, ready to go. The beauty is where I'm stood on a ladder there, right behind me, there's another jumbo arriving, and then you get 2 jumbos going with 4 drills, if you will. So it gets quite crazy, quite confined, noisy, wet. So explosives, we were using mostly Orica Senatel Power Frag. A lot of you, probably most of you, have used some sort of packaged explosives in the quarries, if it's toe holes or bulk holes. There's the pre-split products, Orica Senatel Power Split, 22 mil. That's what we had in them green holes around the edge, around the perimeter. Icon 3 electronic detonators. And then we had some cast boosters, which we didn't need, but we had them, we'd purchased them. So we used them up. Once we'd finished using them, we pretty much just went straight with the detonator into the power frag. It was just because of past orders and things like that we had them. And then when things were getting tight on deliveries with Orica, I got Brexco to bring in some Austin powder, Mulex 2. Pretty much same product as on a Senatel Power Frag, but 700 mil long rather than half a meter long. It's nice working in meters and half a meters. These are 700 mil long, so that's my only bugbear with them. Just a bit more awkward to plan how much you're going to put in a hole. So that's how we got the explosives safely from the magazine down. You know, we bring them across in the Land Rover, put them into that bucket there, and lower them into the shaft. And that's the bucket landed on the bench, unhooked, ready, and it's sort of been unloaded. You could just see in the middle a yellow case with the detonators in, the Icon 3s. And the ladder, actually, that's a good one of the ladders. That's the ladder I was climbing before when I took the photo of the jumbos. So unloading, ready for charging. Bit wet, bit muddy, bit sort of shit up. Can I say that? But you'll notice in the floor, you see the white pipes sticking out. They're literally drain pipes from B&Q, 2 or 3 meters long, cut down into 0.5 meter length. So they're not all the way in them 4.5 meter holes. Yeah, that's us. We've gone and bought the pipe, cut it down, and we've just jammed it in. So once the driller's finished the hole, jam the pipe in, saves all that crap going in the hole. Worked very well. We put like little slits in it, and just jammed them in. Recycled them, by the way. So we would pull them out, charge the hole, and they would all go in a bag, sent back up to surface, keep reusing them. Yeah. Another photo of us sort of laying the pills out next to the holes, get ready to go. And actually, you can see just to the right of Di there, the cones. So those are the 127 mil void holes. Obviously, the drain pipe wouldn't fit in that, so we had to put inverted cones in to try and stop all the crap falling in them. Just another photo of a different blast there, nice and dry, that one. Sort of tidy, things laid out. And then the lads, just the shot fires start charging the holes. Then we have to connect them all together. So with Icon, you'll know we've got the computer. You can just see it in the shot fire's hand at the top. He's the top guy. He's got the blue unit in his hand and just wired up as per the plan on that logger. The other thing on that photo is you can see the chippings in the holes. Many arguments are had over what we should use for stemming, from nothing to water to air to clay. And I won the battle, and I says, listen, 64 mil holes, vertical holes in the ground. I want to do it the quarry way and use gravel. And not many people liked it, but we did it. And there's a bit of a picture of a result after a blast. Just go back slightly cheating, because a blaster's dream, this rock, mudstone, not very difficult to blast. You get away with murder. Horizontally sort of bedded, so it broke up quite easily. Yeah, so I might be making things sound good, but it was, the explosives didn't have to do much work. So firing time, everybody out the shaft, nobody underground at all. And you'll know yourselves from your danger zones. We luckily at the MTS there, we've got a fence around it with turnstile entry and card entry. So it's quite easy to maintain like the danger zone where people are going. So when we were firing, you can see FP for firing point, S for sentry on the turnstile. Everyone was in pretty much that office block there. That's been my home for 4 years. And red is obviously danger zone. Nobody in that area for the blast and the degassing. You might ask why it's a funny shape. Well, just sort of here is the exhaust fan. So basically when we blast, it releases all the toxic fumes. Turn the ventilation on, and it's all sort of coming out of that side of the building there. So that's your danger zone. A couple of pictures of the firing point, and I've managed to sneak in a photo there of my little, again, homemade firing point bottom right. Instead of using the rusty table at the top, we advanced to a nicely painted wooden table. Again, blaster's dream, easy to blast, well fragmented. That's just the typical mudstone that we were going through. There was different strengths to it, but ultimately it all was that sort of colour and strength. Your power split, I was amazed at these results. I would have expected this with granite, a hard rock maybe, a sandstones, limestones, whatever. To get this in 40, 50 megapascal mudstone, where it's not been pre-split, it's like I said, it's been fired outwards, and then the power split last to leave that kind of face, I thought was excellent. Again, in fact, that photo, that's pretty much a whole 4.5 meter blast that you can see that's been taken out. And the next one is drilled, ready to go. Right, how are we doing for time, Hazen? Are we okay?
Oh, yeah.
Yeah. So that's the MTS shaft coming down. Then we got to what we'll call the cavern area. So it's the red box on that diagram there. On here, it's that sort of grey area. So you can see the shaft, that's 10 meters diameter we blasted down. And then we had to start opening up. This starting to get tricky now. So we split that rugby ball shape into 4 blasts, brow 1, 2, 3, 4. By far, brow, the third one there, that's the one that had nearly 2 tons in bottom left. That's by far the most complicated blast I've ever had to plan. So I've done loads of quarry blasts, loads of toe shots, loads of 3D modeling on Quarry X. I've used Shot Plus and everything, but those holes there, some of them are at 50 degrees. So at the where you stood, they're only super close together, but at the bottom, I was trying to keep to 1.5 meters apart. It took ages to plan this. And then brow 4 a little bit smaller. So yeah, four big complicated blasts, and you can sort of start to see through these photos how the booms starting to have to go onto angles and things. So like Sam's drilling there, he's sat on the floor because the controls are now pointing downwards, getting some good angles on them. Lots of holes, opening up, bigger area. Angles, drills are basically touching the shotcrete. Charlie there, his controls are now up in the air, so he's having to reach up to drill that one. And then Tom on this one, this image here, that drill couldn't get any further. He's literally reaching as far as he can go with it. It's almost off the ground before he drills it. And you see it's, let's go back one. It's literally touching the shotcrete. It's maxed out on every angle and extension it can do. So we knew after this blast we were at our limit with these jumbos. And I can tell you, see, trying to like keep up with 4 drills with your little clipboard, trying to keep depths and noting at what the hole depths are ready for charging, it was mayhem. But the result was fantastic. So the Galloway stage there, just a nice photo. It looks a bit like a rocket, doesn't it? Coming through at the cavern. And then that photo for me is the best one of the lot. That's after the 4 blasts, and you can see how wide we'd gone from. So the shaft is 10 meters diameter, the circle. The full width of that, length of that, sorry, is 27 meters long, and I think it's 14 meters wide. So it's a lot of, for underground, for me, that was a big achievement to get to there. So then we had to start tunneling into the purple. But I just said before, the jumbos were at the maximum limit, so we couldn't use them anymore. So we actually ended up getting hand drills in. we couldn't get a typical underground jumbo in yet. We didn't have the room. Although that cavern's quite big, if we'd have put a jumbo down there, we'd have blasted straight onto it. So we couldn't damage that. So we had to use hand drills. And that's that plan there. That's our very first hand drill. And there's a before, there's an after. They wouldn't allow us, you're not allowed to, you can just see the yellow mesh on the right. So we were only allowed to take sort of just over half of it in one blast while we supported it, and then we were allowed to take the other half, sort of thing. And we kept doing that, That's that first blast. But again, we've switched now from 64 mil holes to 38 to 41 mil holes. We've dropped from 53 mil power frag down to 32 mil power frag, still with the icons. We've now switched from chip-ins as stemming. We've now gone to clay because the holes are in the wall, so we're pushing clay in. And the result was great. When I took that photo, I thought it was pretty good for me to get that sort of fragmentation. Yeah, and actually you can just see to the right of the photo, you see the little mini digger. So the mini digger was used to drag the material towards the center. Again, sort of hole barrels in the roof. And bit by bit, kept going, mini digger, hand drilling. We started to tunnel into them purple, what you saw as purple on that diagram before. Amazing, really. Amazing that I kept so clean and everyone else did all the hard work. So eventually we could get the jumbo in. That's it arriving second hand. But how do we get that through them two bucket wells? There they are again. There's your 1.9 meter diameter bucket wells. Well, you take it all apart, feed it in little bits like a Meccano set, and build it back up again. Again, something I thought was quite amazing, because the other underground project I was on was a tunnel where we just used to drive everything in and out, the jumbos, Land Rovers, everything. Here, no chance. 335 meters down, vertical hole. You've got to get the kit down, so you've got to take it all apart and build it back up. And that's it, drilling. So we've now shifted again back to 64 mil holes with the jumbo, back to the 53 mil power frag. Another piece of equipment we bought, two of them. Well, how do we get them down? Well, look at the size of the holes. Take them apart, build them back up, and that's what they look like, ready to go. I was just super impressed with how the guys managed this, planned it, executed it. Kept tunneling away. Mini digger again on that photo, feeding the bucket just behind the Toro. You can just see the bucket on the chains. So I think if I just push that again. Let's just go back one. That is where, so you can see the 3D image. That's what we're calling phase one of the MTS. It was to get them tunnels out there. They do go further on, but that's phase two. So phase one was to complete that. Anglo slowed the project and paused this shaft in May, June. So that's as far as we got there. So we were flying on, but we never actually finished phase one there. So that's sat waiting now. When we restart the project, we'll carry on with that. Okay for time? Yeah.
Yeah, around the time.
Yeah, right. Try and fly through some of this now. Just want to show you this. So, world's first number one. You'll see a red arrow there. Service shaft, cubby number one, needs to be excavated. So that's what they look like. It's the water pumping station, 40 meters long, 4.2 wide, 4.6 high. So Brock 200 with a hydraulic pecker to try and take it out. And that's the lads taking the top half of it out. Took too long. Time is money. So the floor, get the blasters in. We'll blast it out. It's going to be far quicker. 108 holes, 41 mil diameter, plastic pipes again, drilled on night shift, and that's us going in on the day shift to blast it out. Charge it up. There's a before. Oh, by the way, sorry. Where I've took that photograph, I am on the SBR. It's about 20 million pounds worth of equipment, only 3 meters above that blast. Would you park your excavators and dumpers this close to blast? No. So we couldn't get it any higher than where it is. So there's quite a lot of pressure on this blast, but it all went successfully. In fact, it went that good. I've never seen in any quarry blast, you know how you've got the power trough, as we call it. So you walk along, you have a look at your blast, you've got the power trough and it humps down. This blast was so good when you walked in over this hump and into the cubby, you could walk onto the freshly blasted floor. It had moved it that much. You were walking on the hard floor. So I'm pretty impressed with that. And that's what it looked like excavated out. Top half peckered, bottom half blasted. So all of the cubbies, 7 more cubbies to do. We've only done 3 of them so far today. But when we got to the production shaft, cubby number 1, let's not use the Brock 200 anymore. Let's not try and peck it. Let's go for the full blast now. 4.2 wide, 4.6 high, 3 meters deep. 6 of them will get us to 14, 5 or 6 blasts will get us to 14 meters. So that's us preparing what I call world's first number 2, because again, the SBR is only parked 3 meters above, but this time we're going for the full face. Yeah. SBR parked super close, but we got it. No damage. Again, sort of nice, tidy roof, some hole barrels. And some photos there. Then blast number 2, just quite a funny example for me. This little machine, once we got 6 meters in, how do you get the blasting material out to the center of the shaft for the SBR to suck it up? You need the IMCO in, again, lowered in bits, taken apart, built back up. But the only problem is, so that's what it's going to be used for. We're now sort of 6 meters in. You need to get that blasted rock back out to the center of the shaft. The only thing is, it's not got much room, so it's parked only 4 meters away from the blast. Again, would you park any of your dumpers there when your blast is there? Again, for me, bit of a shock, but these machines are bomb-proof. Blasted, dust it off, plug in the air lines, electric, go again. No damage, keep using it. And then there's a photo of us sort of getting to the last blast of that cubby there. How are we doing for time, Hazen?
Yeah, 5 minutes.
Another 5, yeah, right. So I mentioned this band of sandstone. You can see on the diagram in yellow, there's a potential that we might need to help the SBR with that, with some blasting. So you can see a thin orangey yellow line with the red arrow on. That's at about 510 meters down, whereas the sandstone's at 800. And when the service shaft, which is the one with the little man rider in there, when that went through, when they motored through that band, they realized it was quite hard. So when the production shaft got to that same level, we carried out a little test blast. So this is directly underneath the SBR. So now that's why I'm calling it world's first number 3, because we've gone half a blast to one side, a full blast on another side. Now we're directly underneath the SBR. No pressure, but this time, there's your 32mm power frag. Because I was so concerned about damaging the SBR, we were now cutting the pills. These are only 400 grams each, and we're cutting quarters off them. We're not talking about kilos. The whole blast only had 32 kilos in it. The cost of the detonators was about 5 times the price of the explosives on this blast. So it's, again, amazing. You're going from sort of different blasts, some of 64mm holes with plenty of kilos, to this now, we're down to like grams, basically. Again, bit of a nightmare with the Herring Connect wanted us to have two detonators in the holes just to prevent any misfires. So that's why there's so many wires, 190 wires. I use this calculation a lot for it, scale depth of burial. Don't know if any of you have seen it before. And there's a before, there's an after. No damage. I think we damaged one gas sensor on it, but nothing major. Good blast. So I could stop there if you want, Hazen. The rest of it, I've just got some images of the magazines and training and Land Rovers and things like that. It's up to you.
No questions, I think.
Questions now, yeah.
Yeah, just conscious if there's any questions.
Yeah, if there's any questions online as well. There's a blast spec for you. I'm not sure. Is there any questions online, Debbie? Not at the moment.
No,
Any questions?
Yeah.
Okay. Any questions from the room?
How many work on each shift then? If you've got night and day shift? And are the old drillers on shop fires, or do you have drillers and shop fires separate?
Yeah, so the mining crew, there might be, say, let's say 10 guys on a day shift, 10 on a night shift, for example, and they would double up as everything. They would drive them grabs, they'd drive the jumbos, they'd do concreting, ground support, meshing, everything. So they all started to learn every role. And then when we went tunneling, they did the same. They all started to pick up all the different jobs, which is obviously great. Multi-skilled, anybody's off, another guy can jump on. But yeah, I'd probably say I'm just probably about 10 guys on each shift.
I've got a question from online
Yeah.
asking, did you experiment with timings?
Yes, I did. In the shaft, I did. And then the geology bit me in the ass a little bit because I was playing with the burdens and spacings as well. And we got one bad blast where the geology changed halfway through the blast. So what happened then was my focus came off the timing and just stuck with the powder factor and the hole pattern. And I kept changing. So I've got a geological log of all the way down, and I kept changing the pattern to match the geology to save time, to try and cut holes off. So I sort of ignored the timing then and never really played with it after that.
Okay, thank you.
Yeah.
What's your time frame for all this to be completed, Neil? Is it how far on here? How much is more to do? Or?
Well, the project, because it's been paused now, that's obviously like slowed it down, but we're concentrating on one shaft. So at the moment, I don't think there's a timeline as such. I don't know if you know any more about that, Charlie.
It's sort of 2026, 2027 for it to try and get the service shaft through, but there's a lot in care and maintenance with it, so it's all just still rolling on, and all our focus has gone onto one shaft.
Just while Anglo rejig the finances to see where they're at, And then obviously when it gets up and running again, then they'll put a fresh timeline on it, I would have thought. But there was an image there, I'll just quickly slide back. So I think this is quite amazing for me that's what we might call phase 2 at the MTS. I mean, phase 1 was big enough, and that's just that purple area there. That's where we've been working for the past year or so. That was a plan. So there's quite a lot to do.
Neil, with your practice blast on the sandstone and the fact that you might do a little bit of loosening up on the sandstone further down, we're going to deal with the known water problems of that sandstone with the grout curtain format. What's the risk of blasting and fracturing that curtain?
Yeah, so there is that risk, and then we're looking at that at the moment, whether we can just keep the MIC down, the amount of charges, like the hole depth down, to prevent that shock wave from damaging it.
So has it been the amount of water down there from production shaft that they expected?
I don't know what the figures are for the expected versus the actual.
It was quite high pressure, hundreds of bar, I believe.
Yeah, again, I'm not really on them shafts. I'm sort of just waiting to see if they need any assistance at the moment. I don't really know any of them sort of figures on the water, really. Yeah. Is there anything else online, Debbie?
No.
What's the timescale for the completion of the whole job?
That's what we were saying, really. We would have said 2030 before the pause, but now I'm not sure, because I don't know where we'll be at when Anglo rejig the finances and then they decide how long they want, what sort of targets they want to hit. But that image alone, there's 3 or 4 years work there. Just even the blue sort of tunnel alone is something like 12 meters wide, 12 meters high by 500 meters long. So it's huge. A lot of rock to be blasted and then sent out that 10 meter shaft here. Yeah, so really what you're seeing there, you're just seeing, I've been on the project for 4 years. We only started blasting kind of after I've been there for a year. So what you're seeing there in all them photos is pretty much 3 years worth of what we've achieved so far on the blasting front. Yeah. Hand drills, jumbos, wet, dirty.
Not you.
Not me, but I did chuck a photo in at the end just to prove that I do a little bit of dirty work. There. I've got 1,000 photos and only 2 of them have got me on them. Look, I'm normally on the other side of the camera. No, it might not even be me. Yeah.
I hate that mention the M word, but have you had any misfires down there, Neil, or not?
Yeah, we have had them. Yeah, different reasons. Bit of dead pressing, bit of maybe overcharging where the pills have ejected out. That was in the early days when we were sort of just getting going, so we were getting used to it. But yeah, we have had them. Yeah, you don't really get like the cut-offs or anything because of the icons, but certainly dead pressing. We've seen that a few times.
Neil, I'd just be interested, obviously away from an underground world, but guys that blast on the surface, have you come across any misfires or any problems with those sort of systems that are out there now? Dropping into the room, really, I think. We've got
With electronics, or any
Well,
detonators.
any really, it's a-
Yeah, I mean, I've not seen any dead pressing in quarries. The only problems I've seen with electronics in quarries really was like where you might get the odd no log. So it's either got a cut wire or it's, so if the wire was cut completely, you're gonna get no reading off it. If it's just slit or chafed or something, you might get some high leakage. So there's the odd time where you wouldn't be able to register that detonator. But in UK quarries, we tend to put 2 detonators in the hole, so there's always that second one to help back it up.
We've had that pressure with hybrid systems, especially if I'd one double deck, double, triple deck. Quarry in Lancashire from competitor, very historically had a lot of problems with deck pressing, but they was on a hybrid system.
Right.
So triple decked holes, not very tall face, but a lot of boring grass as well. And they used to have a substantial amount of misfires.
Yeah.
And the manufacturer there always put it down to deck pressing.
Yeah, I know that the 2 main manufacturers are, I think they give out a bit of guidance on minimum haul distances and things like that. I mean, when I was up at Glensander there, we were probably exceeding the haul distance anyway all the time. Non-Ls, shock tube detonators, I have seen the odd misfire. And I'll be honest, even one of them was my own where I've not connected it in, so there's a human error. But you can get cut-offs with the shock tubes, but then we could cover the connectors so that you try to reduce that shrapnel. Yeah, I mean, there's advantages and disadvantages to both of them, and a lot of the time it comes down to cost. These Icon 3s are expensive, well, super good for what they do, but everyone looks at the cost, don't they?
If there's no other questions, any other questions online, Debbie?
No, nothing online, thank you.
Well, thank you very much, Neil. That's been very informative. Thank you for those that have joined us online, and thank you for those that have joined us here. Thank you very much, Neil.
Cheers.